Hello everyone, this is Mr. O. Today I'm gonna be teaching you how to calculate for volumes. This is a very basic lesson for those who have never learned about volumes. For this topic, you need to first make sure that you have a good background knowledge of different types of areas. Here are the 4 shapes that you must know to learn today's topic, okay? If you can't memorize the formulas, I recommend you to take a screenshot of this or pause the video for a moment and write these on your notebook. I'll assume you have done what you needed to do. Let's move on. Before we start, I have a pop quiz for you. How many cubes do you think are there? You may pause the video for a moment and figure it out. So let's see. I'm gonna pull out the base here. And how many are there in the base? 8 cubes, right? Now, it looks like it has 5 layers of it, so probably 8 times 5, which is 40 cubes, so we have 40 cubes in total. This is a simple stuff, so I thought that you had a hard time answering to this question, right? Okay, there's a reason why I'm giving you this kind of question. You see, that was kind of a volume you just found. Volume is simply area times height. So, we are now in 3 dimensions. Let's have an example. We have a rectangular box. The length and width are 3 cm and 2 cm, and the height is 10 cm, right? What is the volume of this rectangular box? You know how to find the area of the rectangular base. In this case, it is 6 cm square, right? But now this base stretches up by 10 cm. So base times height is going to be 6 times 10, right? So that is going to be 60. And this is our volume. What is the unit? Centimeter cubed. Or we also call it centimeter to the power of 3. This is because volume is a 3-dimensional quantity. Area is 2-dimensional, and that's why it's centimeter squared or meter squared, something squared. But volume is gonna be something cubed. Does it make sense? So, what we just did here was we found the volume by multiplying its base area by its height, okay? Here is the second example. We have a cylinder that has a radius of 2 cm and a height of 10 cm. What is the volume? Can we find the volume of this cylinder just with these 2 numbers? Yes, let's think about it. What is the base of this cylinder? It's this circle, right? And what is the area of this circle? Pi r squared, so 4 pi centimeter squared, right? This is our base area. And what did I say? Volume is the base area times height. So it stretches up by 10 centimeter So the volume is 4 pi centimeter squared times 10 centimeter, which is going to be 40 pi centimeter cubed. So the volume of this cylinder is 40 pi centimeter cubed. If things aren't clear to you yet, I recommend you to go back to example 1 and watch it again before it's too late. If things are clear to you so far, let's move on to a bit more challenging example. So we have a triangular prism here. You could also think of this as a tent. It won't matter. Let's try to find the volume of this thing. So where is our base area? Is it this rectangle? The rectangle is 4 times 10, so it should be 40 centimeter squared, right? But should this be our base? Let's think about this. The height is 3 centimeter. So if we stretch our base up by 3, we are actually getting this volume. This is 40 times 3, so 120 centimeter cubed. Is this correct though? No, we shouldn't be stretching that area. Just because I'm calling it a base, in math, the base doesn't really mean the bottom one. The base is the one which shape could stay the same for stretching. This triangle is the base. And what is the area of this base? 4 times 3 divided by 2, right? Which is 6 centimeter squared. And we are now stretching this triangle like this by 10 centimeter. So it's consistent, right? So 6 times 10, it should be 60 centimeter cubed. And in fact, this is correct. Do you now get how we are finding the volumes? So we pick a base that would stay the same throughout the stretch and multiply by how much it's stretched, okay? Now, let's try to find the volume on our own. Pause the video for a moment and try to find the volume of this trapezoidal box. Be careful this time. The dimensions are in meters, not in centimeters. You see that? The method is still the same, but I'm just saying the unit is different. So don't answer it in centimeter cubed or something. That's all. Alright, let's do this together now. So what is the first thing that we need to do? Decide which one is gonna be our base, right? And what would you choose it as a base? Of course, this trapezoid. Because we'll just need to stretch this by 12 meter up to get this volume, right? The area was 21 meters squared. You should know that. And times 12, that gives 252 meter cubed. Good job if you got this right. Okay, next question. You may also pause this and find the volume of this pipe. Alright, so let's do this together now. What is the base here? It's probably this circle, no? Because this circle can be stretched to make this pipe. And be careful. I gave you the diameter of the circle, so the radius should be 3 meters, right? The base area is 9 pi meters squared. Some of you may have been fooled by this number. This is the diameter of the circle, not radius. So our base area is 9 pi meters squared. And we are stretching this by 20 meters. So the base times height should equal to 180 pi meter cubed. So the volume of this pipe is 180 pi meters cubed. I guess that was easy as well. Now this one is a bit challenging. We have a toilet paper here. It's a green toilet paper. So what I'm trying to say is the inside is empty. So there's no volume inside. Remember that, okay? You may pause the video and try to solve this question on your own. Okay, for those of you who have waited, what should be the base in this case? Is it this circle that has the area of 25 pi centimeters squared? No, the base should look like a donut. We have to take out the area inside, right? So the area of the circle inside is 9 pi centimeters squared. So let's take this area out. Then what should be the remaining area? 16 pi centimeters squared, right? Now we can stretch this area up by 10 centimeter to make the toilet paper. So the base area times height should give you, I hope you got this right. If you didn't understand what just happened, go back a few minutes and watch it again. Alright, so this is our last question for this video. So we have to find the volume of the stairs. What is the base? It should be this one, right? And this looks like as if there was a rectangle before, 6 by 8 rectangle like this, but this part got cut out. Can you imagine that? So how much is cut out? So here it says 3 centimeter. The total length is 8, right? So this should be 5 centimeter. Do you agree? What about the vertical length? The total height is 6 centimeter and we have 2 centimeter here. So this should be 4 centimeter. Does it make sense? And we're cutting out this area. The total was supposed to be 6 times 8, which is 48 centimeter squared. But this part is cut out, which is 4 times 5, which is 20 centimeter squared. The leftover area should be 28 centimeter squared. So in the end, this is our base area. Now, we're just stretching this to the back by 7 centimeter, right? So 28 times 7 is 8 times 7, that's 56. And 2 times 7, that's 14. So this will become 19. Am I right? So, therefore, our volume is 196. What is the unit? It's in centimeters. So, centimeter cubed. This is our answer. Alright, so we have tried several questions together. I'll give you a homework today. You have to find the volumes of these two objects. Both have holes here like this. Okay? I'll provide you the solutions in the next video. I hope you understood the basic concepts, and I'll see you next time. Bye.